Don't confuse. As such liquids we don't image. As such liquids, the samples. As such samples we don't, as such liquids we don't know, but the way how to handle the liquid samples. If you have a nanoparticles dispersed in a liquid, then drop cast and dry the sample. That is good enough to handle the sample. When you drop cast the sample, make sure your particles are 10 nanometer, 20 nanometer for example. Then your surface substrate what you are taking should be lesser than the surface roughness should be less than your particle size. Otherwise, because if you drop cast on a normal carbon tape which has a big pores, and if you drop a 10 nanometer, then it's difficult to handle. They get the picture. So the jugaad what you normally research scholars do
so,
on an aluminum foil. You can easily just drop it, which is easily available. Semiconductor, those who are working in MEMS, they will have the silicon wafer, but materials are difficult. So you can have the sample on an aluminum foil without wrinkle. So at least you can image those samples. Or if you have a quartz, you can do that sample.
So what if the particle size is lesser than 10?
No, less than that. Yeah. So that's what surface. Where I'm coming is, you should have a surface which has a surface roughness less than your particle size.
So is there any restrictions of using the solvents which we are using for droplet?
If you whatever the solvent you use, after drying up only we will take it. If you use water base, then drying all those things will take a lot. If you have an alcohol base, it is easy to dry up. But thing is, which should not affect your particle size or your chemistry or morphology of your sample. Such a buffer you have to keep. Buffer solution.
Sir, is there any limitation on what kind of material is there? Like in XPS, they sometimes avoid to do with sulfur groups. So, is there?
Polymer, for example, the example I make polymer normally when you take if anybody works on batteries, the battery separator itself is the insulating polymer, right? You use cell guard. Yeah, that's a cell guard which you use. If you do the cell guard in SEM, even at 100 volts, the pore size, because the polymer, the functional, the batteries, whatever, the pore size is very important. When you have the example I'm taking as a battery or a fuel cell, which the membrane electrode assembly, or it has in a fuel cell. Once you have the membrane electrode assembly, the insulating layer is, they tell you the complete the ion transfer, the ions transfer and the rate of transfer, and that will finally give you the efficiency of that particular cell. So if you are not able to understand the porosity or the size of these pores after certain cycles of electrochemistry, because you do a lot of electrochemical reactions through that polymer, and later you will understand how much of this material from one electrode to another electrode it transfer, what is the active area after certain cycles. That is why our batteries also will lose the efficiency after certain cycles, right? Why? Because there is a lots of change in this membrane electrode assembly. So those are all information you can image, but I can say it's difficult to handle such a sort of deep sensitive sample. But this system has a capability of handling the polymer sample. Only way you have to handle is the low K method. So this is your separator, battery separator. It's a cell guard. But these imaging cell guard is should be little bit tricky. But you can handle those things in this FPC. But normal SEM, you have one more SEM in center basically normal SEM. I don't think you can handle it. And this is the strength of this system. You can submit the sample. But only thing is don't submit the sample without giving the information. If you submit the sample, then we cannot understand what parameters is suitable. By the time maybe this electron beam induced effects will destroy the features, right? So give complete details and what exactly you are looking for. Then he can understand the detector. Each detector has its own advantages. So if really looking for a high resolution image, if you are really looking for a true topography information, difference between topography and true topography, you know, right? If you are looking for a material contrast information, if you are looking for a thickness of the thin film, or if you are looking for the fibers arrangement, because there you need to go for a little bit high depth of focal. So try to give as much as maximum information so that you can reach your expectation. If possible, give some already published data related to your sample and then submit it, then definitely I think understand. If no more questions, I think this is what the demonstration today we planned for STEM. All the other things we completed in the last slide. So if you are further interested to see one or two STEM images, yeah, you can stay here. Otherwise,